everybody. This is Miss Horn and Miss Lane, third grade math teachers from Farmington Elementary. Hey, Miss Lane, how are you?
Hey, how are you today?
I am good. Are you ready for some math?
I am so ready for math today.
Okay, well, today we will be talking about equivalent fractions. And we're going to start with our objective. Our objective is demonstrating your understanding of equivalent fractions with the number line and other models. What are our essential questions, Ms. Lane?
Well, we've got 3 essential questions today, but I'm going to add one more in because I want to know really the definition of equivalent first. So we do need to define that word. And then number 1, what are equivalent fractions? Number 2, how do you use visual models to show equivalent fractions? And then number 3, how do you create your own equivalent fractions? So let's get started.
Equivalent fractions. What does equivalent mean? Equivalent means equal in value. So when we're talking about equivalent fractions, what does equivalent fractions mean? Equivalent fractions are fractions with different numerators and denominators that represent the same value or proportion of the whole. So in the classroom, we use fraction bars a lot. And you can see here that we've got different representations of the whole, which means just different numerators and denominators which take up the same space. So here we've got the black piece is our 1. The orange pieces, we have 2 different pieces. So it's been partitioned into 2 different pieces, 1/2 and 1/2. So adding these together would be 2/2, which also equals the black piece, which is 1. The greens are thirds each, so there are 3 separate pieces. So 3/3 would also equal 1. The purple are 4 pieces, and they're all 1/4 each. So adding those all together, you would get 4/4, which equals 1. We have 5 pieces for the fifths. Adding those all together would be 5/5, which equals 1. The red pieces are each 1/6 of a fraction or part of a whole. So this would equal 6/6, which would equal 1. Then we have our 1/8. So we have 8 pieces of 1/8. Added all together would be 8/8, which equals 1. And then we have our tenths as our yellow pieces. So we have 10 1/10ths, which equals 10/10ths, which equals 1. Again, all 10 of these pieces is the same proportion as the one black piece. So how does this work? Let's say I wanted to show you that the 2 1/2s are the same space and proportion of the whole as the black piece that is 1. So you can see that the 2 orange pieces take up the same space. Let's return those back. And let's go down to our fourths. These 4 pieces take up the same amount of space and is representing the same proportion of the whole. So 4 pieces of 1/4 would also equal 1. Another way you could do this and find other equivalent fractions, let's say that I wanted to find equivalent fractions just that equal 1/2. So I'm going to take my purple pieces again and see how many pieces fit on the fraction bar. So you can see 1/2 equals 2/4. What if I wanted to take the 8ths and see how many 8ths would equal 1/2? I'm going to use the other side of this. 1/8, 2/8, 3/8, and 4/8. So 4/8 is an equivalent fraction to 1/2. These are just in smaller pieces, but they both of the fractions are the same fraction. They are called equivalent fractions. Another way we show equivalent fractions is actually by using what we call a pie shape or a circle. And I've got some Legos here that I like to work with Legos. In my representation here, the blue Lego is going to be the numerator, and altogether we're going to count the pieces for the denominator. So I have one piece out of two pieces that represent this figure. When I represent this by using a pie graph, I would actually take the numerator, which is one whole piece, out of two, and that would equal 1/2. So let's look at our next one. We're looking for our numerator, which is our blue color. So we have 2. So the numerator of the fraction would be 2, and the denominator would be all the pieces. So 1, 2, 3, 4. This would be 2/4. Well, let's look at that on a pie graph. So here, we're going to have 4 total pieces, and 2 of the pieces are the numerator. So you can see in comparison, these fractions, although the numerators are different and the denominators are different, they are still occupying the same space. So 2/4 actually equals 1/2. So let's look at our next one. Again, our blue color is our numerator. So our blue is 4. And then we'll count them. 1, 2, 3, 4, 5, 6, 7, 8. 4 8s. And now let's do our representational drawing. So I have 8 pieces here, and I'm going to shade in the numerator. 1, 2, 3, and 4. So I'm shading in the exact same place as I shaded in here. They're just in different numbers of pieces. So 4 8s equals 2/4 equals 1/2. Now let's go to our last one. We have 6 as our numerator. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And now we're going to represent that in our circle. And we're going to shade in the numerator. So 1, 2, 3, 4, 5, and 6. And you can see that we're still shading in the exact same amount. So 6/12 equals 4/8 equals 2/4 equals 1/2. Now let's look at another way that we can show this. We're going to look at this one here. Using a bar graph, we're going to show this fraction right here. So we have a total of 1, 2, 3, 4, 5 pieces. So that would be 5 as the denominator. Oh, my pencil. And the numerator is our black color, so 1/5. So I'm going to partition my bar into 5 pieces and shade in the numerator. So this is 1/5. Now I'm going to look at my next fraction. I'm going to count the dots on the black. 1, 2. So I have 2 as my numerator. I have 2, 4, 6, 8, 10. I have 10 as my denominator. And now I'm going to show you on the bar graph. I'm going to first copy what I've got up at the top. So we're going to do this into fifths. And then we're going to partition it into tenths. And shade in the numerator. So we're going to shade in 2. And you can see that what I have shaded in at the top is the same that I've shaded in at the bottom. They're both occupying the same space or proportion of the whole. So 1/5 actually equals 2/10, and this is how you can create equivalent fractions. Now Ms. Horn is going to teach us how to make our own fraction strips.
Thank you, Ms. Lane, for showing us equivalent fractions with manipulatives. Now we're going to move on to showing equivalent fractions in visual models and number lines on a piece of paper. You can grab any notebook, grab a piece of notebook paper. I prefer notebook paper just because it has these lines and it will help me draw these fraction strips a little bit easier. I'm going to start with the first fraction strip. And this one is going to represent 1 whole. I'm not going to partition it at all, just to show 1 whole. Because remember, fractions are part of a whole. And we're about to demonstrate on more fraction strips of how we partition, how we cut up the whole into smaller equal pieces. So I'm going to keep that as is. I'm going to make a little bit of space down here and make my second fraction strip. I want to make sure that it's the exact same length because it's representing the same whole. Now, this is representing 1 whole. We're not partitioning at all. We will, however, partition this one. We're going to go ahead and split it up into 2 pieces. So in order to do that, 2 equal pieces, there's multiple ways, but today we're going to just do this way, show this way. I could have done the line this way. I could have done it diagonal, but we're just for time's sake, I'm going to show it this way. So 1 whole partitioned into 2 parts. Okay, so what does that mean the denominator is? The denominator, the total amount of parts in the whole. That's right, it'll be 2. Each part is talking about 1. This part is talking about 1. This part is talking about 1. So our numerator, the number that represents what we're talking about, is going to be 1. So looking at the whole, this is just 1 whole part, not partitioned at all. And now this fraction strip is split into 2 equal parts. one half, and another half. 2 halves, as you can see, makes a whole. Let's move on to show how to make fourths. I'm going to look up here, make sure that my next fraction strip is the same length. It's not going to be perfect. Okay, so we have 2 equal parts right here. To show fourths, we're actually going to use this same line. It's going to help us make fourths. I'm going to cut this fraction strip into halves. Well, what am I going to do from there? I'm actually going to split my halves in half. I'm going to double each part. Now, take a couple of minutes. What does doubling mean? When you hear that word doubling, what does that mean? Correct. You need to double each part. That means you need to put each part, partition each part into 2 parts, 2 equal parts. Now, looking up here, our denominator was 2 because there were 2 parts in the whole. What do you think the denominator would be for these parts in the whole? 1, 2, 3, 4. Great. The denominator would be 4. That is the total amount of parts in the whole. Now, each individual part, if I shaded that part, it would be how many parts? It would be 1. If I shaded in that part only, how many parts would that be? 1. And then so forth. And as Miss Lane showed you before, 2 fourths would be equivalent to 1 half. 4 fourths, 1, 2, 3, 4. 4 fourths would be equivalent to 2 halves, or a whole. Moving on to number lines and how we would show equivalent fractions on those number lines, I actually can use my visual models to help me draw a number line. So, looking at the halves, looking at my rectangle, I can actually make my endpoints to where the rectangle ends. I'm going to draw my line. This is why I use note paper to use this line. I don't want my line to be all over the place. And there's a number line. It's not partitioned yet, but it is a number line. What do you think I will be partitioning this number line into? I'm looking at the above rectangle. If this line is right here, and I've been using my rectangle lines, this is for that endpoint, this is for that endpoint, do you think I'm going to use that line? Yes. I'm going to use that line, work directly under it, and mark it right here. I have now partitioned my number line into 1, 2 parts. What these are called are intervals. What does that mean? An interval is the space in between 2 tick marks. An interval would be showing 1 part. Just like from here to here is showing 1 part out of the whole. From here to here is showing 1 part out of the whole number line. Next is, how do we label the number line? We've labeled our fraction strip. How would we label our number line? If from here to here is 1 part of the whole, would end up being 1 half of the whole, this would actually be, what would be right here? What fraction would go right here? Is this any part right here? Is there any space in between 2 tick marks right here? No, it's the beginning tick mark. So it would actually be 0 halves. 0 halves. Why 0 halves? Because you haven't gone anywhere yet. If you did shade in, if you did go forward 1 part, this would actually be 1 half. Why? Because if I shaded or if I jumped, whatever way you want to look at that, that would equal the 1 half. This is my starting point. 0 halves. It's kind of like when you start a race, you start at 0. And then when you go, okay, I went half a lap, well, you reach that point to reach half a lap. You're not going anywhere from the starting point. So that would be 0. The next tick mark, so this is 1 out of 2. You know that there's only going to be 2 parts in whole. Another jump, another shaded part would be 2 out of 2. 2 halves. So as you can see, comparing both of these, if I shaded this, it'd be 1 half. If I shaded this, that would also be 1 half. If I shaded all of this rectangle, this hole, it would be 2 halves. But if I shaded this whole number line, it would also be 2 halves. Do you see the comparison? Let's go ahead and show a number line for fourths. Again, I'm going to look at my rectangle. My number lines endpoints are going to match with the rectangle's endpoints. I'm going to use this line. Not the straightest line, but that's okay. And again, I'm going to use my lines from my rectangle to help me create my number lines, or my tick marks on my number line. So again, we still have that halfway point like we did up here. I'm going to still use that same line. I now have 2 parts. I need more than 2 parts. I need 4 parts. Looking up here, how do I make my 4 parts out of my 2 parts? I'm going to use this line that they used up here, that we used up there. Match it. Do you see the 4 parts on my number line? Remember, an interval is the space in between 2 tick marks. This is a space in between. This is a space. This is a space. This is a space. We have 4 spaces. Do you think that we can label our number line like we labeled our number line up here? What did we say about that first tick mark? Is it going to be 1/4 right here? No, it'll be 0/4. 0/4. We haven't gone anywhere yet. We haven't shaded anything yet. This is our beginning point. It would be 0/4. Moving forward, shading in or getting to that next tick mark will be 1/4. As you can see, if I shaded in this part, it would be just like shading this part, 1/4. Another part would be 2/4. The next, 3/4. And the next, 4/4. Now, looking at these number lines, we've gotten a little better at labeling them, partitioning them. Can you see any equivalent fractions from this number line and this number line? Which ones do you see? Well, we talked about those the zeros in the numerator, 0 halves, 0/4. Now, they may look different because the denominator is different. But even though the denominator is different, it is still on the same place on the number line. And because it's on the same place of the number line, that means that they are equivalent. I'm going to go ahead and circle them so you can see that they are equivalent. Now, where else is equivalent? I have a 1/4 right here, but do I have a tick mark for that place on my number line with halves? No, I don't. So there's nothing on this number line that is going to be equivalent to 1/4. What about this tick mark and this tick mark? Do they line up? Yes, they're on the same point on the number line. It is halfway through this number line. This one is halfway through this number line. Now, they look different. 1/2 looks different than 2/4. Why is that? If you notice, The numerator, 1, and then the denominator, 2. 1 is half of 2. Now with that same pattern, what do you notice about 2/4? 2, the numerator, 4, the denominator. 2 is half of 4. Now again, they look different, but they are still representing a half. Even though this is one big part out of the 2 bigger parts, it is half. These are smaller parts, but what you got to remember, what did we do to this big part down here? We cut this in half, and then what did we do to that part? We cut that in half. We doubled it. So if we doubled it, the amount doubles. The numerator doubles, 1 doubles into the 2, and the denominator doubles. Instead of having 2 parts, it is now 1, 2, 3, 4 parts. Now looking at the 3/4, do you notice any fractions up here that are on the same point of the number line as 3/4? No, because this only has 2, there is not a tick mark up here for 3/4, so no halves are going to be equivalent to 3/4. Lastly, on the number line, we have 2 halves, 4/4. Shade in 1 half, 2 halves, you got through the whole number line. 1/4, 2/4, 3/4, 4/4, you've gotten through the entire number line with fourths. Because they fall on the same point of the number line, they would be equivalent, representing 1 whole. Now, just for an additional model, I was going to show you guys with circles, which I'm not going to be good at drawing circles. Oh my goodness, those are horrible. But just to show you, going to cut these, partition these, this one into halves. To represent this fraction strip, to represent this number line. 3 different models here to show halves. How do you think I would do that to the fourths? Remember, we still use that same line. We use that line to make this along with in our number line. We'll do the same thing for our circle, but do we leave it like that? No, that's not 4 parts, it's only 2. So what do we do to our 2 parts? We double them, we cut them in half. So this would be 1/4, 1/4, 1/4, 1/4. If I shade in 1/2, how many fourths am I gonna shade? If I shade in 1/4 like I did 1/2, well, that doesn't look right. This looks a lot smaller than that one. In fact, half the size of that one. Just like you did half of this circle, it is still half of this circle. It might look different. 2/4 might look different than 1/2, but they are still equivalent. It is still the same amount shaded. Now let's move towards the actual algorithm of finding equivalent fractions. Writing down, I'm trying to find some different colors here. Writing down 1/2 and then having that 2/4. Okay, hopefully that's a better visual. Noticing the numerators. Noticing the denominators. What is happening if these are equivalent to each other? Like we've proved on our fraction strip, on our number line, on our circle models. What is happening to this and this? What's happening to that 1 to become a 2? What's happening to that 2 to become a 4? We've used this word a couple of times throughout this lesson. Starts with the D, kind of cutting things in half to put things in 2. That's right, 2 double, double. Okay, that's another key word. Might want to underline these words. Now doubling, you are doubling the 1 to become the 2. What about for the 2 to become the 4? Are you doubling the 2 to become a 4? Yeah, 2 and 2 make 4. 1 and 1 make 2. So a way that you can double is to, like when you think of that word double, what are you doing? What does that mean to you? It means to have 2 of them, correct? So in order to have 2 of something, you can actually multiply it by 2. 2 times it by 2. 1 times 2 is 2. 2 times 2 is 4. So in order to double a fraction, to make that equivalent fraction, whatever you do to that numerator, you have to do to the denominator. Whatever you do to that denominator, you have to do to the numerator. Do you think we can double this fraction into another fraction that's equivalent to it? Think about doubling fourths. Write that down here. Think about doubling fourths. Think about doubling a 2. What would that turn into? Let's maybe go back up to our fourths number line. What could we do to our number line if we doubled our fourths? Remember, we doubled our halves to make fourths. So if we're doubling our fourths, we're just putting each part into 2 parts. I put this fourth into 2 parts, this fourth into 2 parts, this fourth into 2 parts, and this fourth into 2 parts. If I've doubled 4 parts, that means it's going to be how many parts? Well, let's count. 1, remember this is 0, that first endpoint is 0. 1, 2, 3, 4, 5, 6, 7, 8. We've made eighths. Let's go down here. We've doubled our fourths into eighths. Now, we've gotten our denominator. What's going to happen to that numerator? Remember, anything you do to the denominator, you do to the numerator. Anything you do to the numerator, you do to the denominator. So if I've doubled my fourths and that have made eighths, I'm going to double my numerator. If I double that 2, what does the 2 become? That's right, it becomes a 4. 2 fourths is equivalent to 4 eighths. How do I show that on the number line? I've already doubled my fourths. This would actually be 0 eighths, because it's now eighths. 1 eighth, 2 eighths, 3 eighths, 4 eighths. Remember, that one's important. I'm going to go ahead and circle that. 4 eighths. And I'll keep on labeling just so you know. 5 eighths, 6 eighths, 7 eighths, 8 eighths. Does 4 eighths fall on the same point on the number line as 2 fourths? I'm going to zoom in just a little bit. That's 1 eighth, 2 eighths. 2 eighths make 1 fourth. 3 eighths, 4 eighths. 4 eighths make 2 fourths. And just to continue of showing eighths, we just showed it on the number line. So let's go ahead, and if we wanted to show it, oh goodness, that was not a good fraction strip. On a fraction strip, again, you use those same lines. So I know to cut my halves in half, those would be my fourths. To show eighths, we just said we'd cut our fourths in half, we'd double them, create those fourths again, and double each part. Double each part. And each part would be 1/8. Two fourths equal 4/8. Lines up like that. And if you'd like to see it on the circle, oh gosh, I get intimidated by drawing these circles. Same thing for our circle. We use that half to draw our fourths. Because we need our fourths again. But then remember, we gotta cut our halves in half. How do we do our eighths? We cut each fourth in half. We double each. And now you have 1, 2, 3, 4, 5, 6, 7, 8. Labeling each part, and I'll shade for 1/2 and 2/4. 1/8, 2/8. 2/8 makes a fourth. 3/8, 4/8. So 4/8 would also be another equivalent fraction.
Okay, after everything we've learned today, I want y'all to go over our essential questions again. I want you to come up in your own words the answers. Number 1, what does equivalent mean? Number 2, what are equivalent fractions? Number 3, how can you use visual models to show equivalent fractions? And number 4, how can you create equivalent fractions?
And lastly, reviewing those questions, what do you think, out of everything that you've seen today and thinking about those questions, what do you think our objective for the lesson is? Okay.
Good job today. And officially, I want you to know that Mrs. Horn and I now have a home office, and we officially have a name for it. Ms. Horn, can you show where we're coming from? 2020 Horn Lane, hashtag Horn Lane. So until next week.
Until next week. I think we're pretty creative, Miss Lane.
Oh, definitely creative. Until next week, we will see you. Keep studying and keep healthy.
Bye, guys.
Bye, y'all.